Hello everyone, my name is Alan Ferrandis. Let's wait for a minute for some people to come. Okay, it's 6 p.m. Eastern Time. We are starting the first episode of our data webinars, Core Analitica Data Webinars. So we are starting this first webinar about decision making with visuals and data analytics. Okay, so we are going to start in a moment. We're going to wait for more people to join the live transmission with this first webinar. Okay, great. So while we are waiting for more people to join this webinar, we are going to talk about a little bit about the topic of today and how Core Analitica is starting this series of webinars. First of all, um, I'm a partner, one of the members, founders of Core Analitica, which is a company, analytics company based on Florida, United States. We are going to hold these monthly webinars about specific topics in data analytics, visualization, any kind of data related topic. And if you are part of these transmissions, you will know that we have a website, we have a social network, we have a LinkedIn page. So I would like to invite you to join our networks or social networks such as LinkedIn and our YouTube channel, which is the channel you are watching in this moment, this transmission. Okay, good. Oh, and by the way, we also have a newsletter um, which you can access in our website coreanalitica.com. Okay, so this transmission, this webinar is going to be recorded and will be available on YouTube once the transmission is finished. Okay, so we're going to start speaking about decision making with visuals, visualizations, and data analytics. Okay, my name is Alan Ferrandis, and today we're going to talk about how visualizations, visuals, can help us to make better decisions. First of all, we are going to start visualizing. We're going to start understanding what is analytics, what analytics actually means, and why we need to visualize. So, analytics is a scientific process of discovering and communicating the meaningful patterns which can be found in data. So, analytics is made of two parts: discovering and communicating. Part of what we are going to emphasize today is the communication part of analytics. We need to emphasize the communication, the appropriate communication, the effective communication of these meaningful patterns. Okay, so that's one of the reasons why we need to visualize. Okay, but the main point about analytics is to turn raw data into insights for making better decisions. Okay, so the last mile of analytics is making better decisions. Good. So we have some key parts of the definition of analytics: communication and turning raw data into insight for making better decisions. So this is a definition of Techopedia, okay, which is like a kind of a Wikipedia for tech definitions. Okay, so why do we need to communicate? Communicate because this is data and this does not communicate effectively. Actually, this does not communicate at all. So we need to visualize, transform the data into something meaningful for improving decision making. So by presenting this data, we are not doing anything to better communicate. So why we visualize? Why do we need visualizations? Actually, because we need to have a point to communicate to the world. That's the, the key point of this talk. We need to have a point to communicate. We need to visualize only if we have a point to communicate. Every visualization that we are going to show to an audience needs to have a point. This is this seems like a very basic proposition. Hey, we need to have something to communicate, but sometimes we tend to um, have to create a visualization, to create a card, to create a visual representation of data, and we don't care about what the point of that visualization is. Okay, what is actually that point? This is a compelling finding to share, something that is meaningful enough to be worth of communication. Okay, this big idea, okay, that we found in our analysis, that we need to communicate to an audience, and that we know that it's going to be helpful to make a better decision, to actually for decision making. Okay, this is called a point. Okay, do you have a point? Do you have something meaningful to communicate? Okay, that's the reason why we need to visualize, to communicate better something meaningful, which is called a point. Good. So articulating this point, this meaningful discovery, okay, is what actually generates the answer that is going to help the decision. And this actually drives every visualization. The meaning of visualization is to communicate better this point. Something meaningful, something we want to communicate. Okay, so when we want to communicate, we need to have a point. But maybe when we want to communicate one specific point, we actually might have the reverse effect that we expect. Okay, for example, in this visualization, what we see is that it is kind of deceiving. This visualization is not actually helping to make the decision. Is making the decision a little bit, a little more confusing. Why? Because in this moment, we are in this visualization, we are not representing appropriately these, I mean, the 7.92 and 6.19. Okay, these are two numbers. Okay, but these numbers are kind of similar. But if we see these bars here, okay, the bars do not represent, okay, the actual numbers. Why? Because in data visualization, we need to have something called common zero baseline, which means that all visualizations, especially bars, okay, need to have a common point in which they both start. Okay, and these visualizations, these bars, actually are comparing two numbers, but they do not start from zero. They start from 550. So the effect that these visualizations have is that the opposite. We are not helping. We are deceiving the audience. Okay. So when we want to communicate, it's not only it's not only a matter of having a point. We need to also have we need to have the proper skills, the proper knowledge to communicate appropriately. Okay. So how not to do it? This is a combined bar chart. Okay, this is a bar chart. Actually, it's a column chart or bar chart, but when we have horizontal bars, okay, it's called bar chart. If there are vertical bars, they are called column charts. Okay, so here we are comparing students and parents' perspective. But the problem with this visualization, actually, there's no, I mean, there's not like a mistake here. There's not an error that we need to correct. But this graphic is not optimized to communicate. Why? because here we don't have a point. We don't have something that we are focusing on. Here we are just showing comparisons, okay, of several categories. For example, is active enough, hang out with nice people. I mean, what is the perspective? There are like categories, like 5 categories. Okay, we are comparing categories. In actually, the categories are students and parents, and the subcategories are each one of these. It's a well-balanced diet, is active enough. Okay, but the problem here is that we are not focusing on a specific point. So the graphic is not wrong, but it is not either optimized for decision making. We have changed this graphic. This is the same graphic actually, but we are using now a more appropriate graphic called slope graph. This slope graph is different than the previous one because it is focusing on one specific subcategory. For example, college attendance is the category, the subcategory that is being focused. So this in visualization is called pre-attentive attributes. That is represented by color, size, position. In this, you can see here we have a visual hierarchy represented by color. It's a different color. So this visual hierarchy gives us the possibility to focus on one subcategory. So the audience, when the audience sees this visualization, okay, they know, okay, just by the color that they need to focus on one specific subcategory. And for example, in this case, if we compare here, we don't have a context. Here we have an story, actually a little context. Surprisingly, students have lower expectations to go to college than their parents, half of them. So we are giving context along with a visual hierarchy in this visualization. This is a proper way, it's a better way to communicate with visualization. What is the point here? The point here is that parents and students, okay, have a very different expectation regarding a specific category, which is college attendance. That is a point. And what is the decision that can be made with this? I'm not sure, but when we have a point, okay, that we are communicating, the decision can might be, for example, okay, we have to stress, we have to do something, take action regarding this specific subcategory, specifically in students, because there's something going on with the students. That is the decision that we can make specifically here. So we are making the decision easier for the audience just by having a context in the graph and using a more appropriate visualization. So I have presented here a different visualization, actually a visualization with a context. Here, we're going to talk about later about these pie charts. The problem with pie charts, I don't have a problem with pie charts, but a problem with pie charts is that they are not suited by, they're not appropriate for comparison. But then when are we are going, when we need to use, when we can use these pie charts? We can use these pie charts, for example, when we want to emphasize one specific number, one specific piece of data. For example, here we are emphasizing a little fact, which is only 58% of students expect to go to college. Remember here? Here we have a lot of data, a lot of data points, right? We see a difference here. Okay, we are comparing, okay, college attendance between categories, parents and students. But here we are just emphasizing in one data point, one fact, one number. Okay, and this is a good example of how we can use effectively a pie chart to communicate to an audience. We don't care about the rest of the categories. We don't care. We don't even care about the parent's perspective, the number that represents the parent's perspective. We care about only about these numbers. Okay, and then we can say that only 58 students, which is like much better than expected in comparison to parents. We can say anything we want, but here we are making very clear the point that we want to communicate. So if you want to, in this case, have talk about something called context, okay, which you can actually uh, access this. I have a research about explanatory data analysis, which is part of what I do here, what I research, in which I focus on how to communicate effectively using KPIs, storytelling, and data visualizations. You can access my personal website to learn more about it. Okay, good. So we are going to talk about how to visualize a single number. So we are now aware of what analytics is and why we need to visualize. We need to visualize because we need to make a point. So the case or the scenario that we are going to see now is when we need to visualize one single number, just one single number. Okay, so what stories can be told with a single number? Not many stories, but in the case we can tell the story with a single number. We have some examples. For example, our employees score an 88 average on their ethics assessment, or on average our mathematics students achievement is 64%, or we served 100,000, more than 100,000, and 123,000 clients last year. So we are telling a story with just one number. It could be a small number or a huge number. Other examples are 90% of our consumers prefer our pizza over our competitors, or only 27% of children in this key neighborhood had a dental visit in the past year. So we are telling a story with just one number. We're making a point here. So, for example, in the last statement, only 27% of children in this key neighborhood had a dental visit in the past year. We can emphasize that 25% is like lower than the national average. And then if we make clear this point, if we want to elaborate in this part, we can help decision makers to make a better decision. So it is totally possible to tell a story just with only one single number. So let's visualize now. There is there are cases, there are scenarios in which we can visualize just one number. For example, a single large number. For example, 1 out of 50 millions will die of a snake bite. So this is like a huge number. Okay, we are making a statement here that it is, there's a little possibility, very little possibility that we die out of a snake bite. Okay, we are telling a story here, and we are using just one big number, one single large number. Okay, we talk about pie charts or donut charts. The difference between pie and donut is when we actually remove the center. This is a donut chart. Okay, for example, 63% of children didn't visit a dentist last year. Remember here? Okay, only 27% of children, okay, in this neighborhood had a visit in the past year. So we can actually doing the opposite here. 63%, almost 2 out of 3 children didn't visit a dentist during last year or in a period, a specific period. Here we are emphasizing what? One big number. We are telling a story with one big number, one huge number, one only number. Okay, and now what we can do is we can elaborate on the story and make much easier the decision for the audience. This is like a very small story. We can elaborate a little bit more, and we are going to be making easier any kind of decision for the audience. Good. So if you ask me when should we use this pie chart, I will say, okay, when we want to emphasize one number, big number, small number, doesn't matter. Okay, we're talking here about participation. Okay, so bar charts. Bar charts are very common since bar charts are very effective for comparison. We are using bar charts when we want to compare categories. Okay, so the special thing about this bar chart is that here we are, you see, we have removed the data labels of every other category, which is not the one that we are actually focusing on, which is adult relative. Okay, so here I don't care about any other category, okay, other than adult relative. Why? Because my point, the point that will help to make a decision, is that 57% of these Latino students, Hispanic Latino students, okay, actually communicate with this relative, adult relative, okay, and talk to them about about college aspirations to these adult relatives. So the point here is very, very simple. We can elaborate a little more about this fact, okay, but we don't care about the rest. We care only about this specific part, okay. We're going to talk about now how to compare. We're not telling a story just with one number. We're telling a story with two numbers, okay. So when we tell a story with two numbers, we are actually comparing two numbers. Good. So this is actually a column chart. Okay, this is a side-by-side column chart. There's a technical name. Okay, we're going to name this side-by-side column chart. Why do we have limitations with this type of chart? The problem is that we, in this case, okay, the categories that we can compare, or the subcategories that we can compare, are limited. For example, we have categories and we have subcategories. Here, categories are states, Minnesota, Indiana, and US, for example. And subcategories, okay, are Jones and adults. Okay, there's two categories, two subcategories. Okay, so what we are doing here, the point of, the purpose of this chart is to compare. We are doing a comparison. Okay, what we are comparing? We are comparing categories, which are states, and we are, well, actually states and the whole population, United States, and we are also comparing subcategories, which is Jones, young people, and adult people, adult population. So here we can see that adult population, you see the A there to the right, actually suffer more from obesity than the young population. But what we can see here is something very, very not special, but something very specific. If we want to compare more subcategories, we are limited. Okay, we don't have that much. We have a space, but we, as an audience, we don't have a lot of concentration to compare because we are here. We are compare. We need to compare the numbers. Okay, so we are limited to just a number of these subcategories to compare. So, but this is not actually a problem. This is a way, this is a call for optimization of this type of charts. So when we compare, for example, I just spoke about how we are limited to, in order to be, in order to make this chart understandable or easy to understand, we need to have just a very limited number of subcategories to compare. The problem here, for example, is that we are comparing seven categories. Actually, we're comparing six categories. The categories here are region, and the subcategories here are the years. But when we have 6 categories and 7 subcategories, we are creating something cognitive load. We are making very, very difficult to understand this chart. Plus, what we can see here, we can notice here in this chart is that we are not making a point. If we, as a member for the audience, see this chart, we don't know where to pay attention to. We don't. So what we need to do here is to simplify this visualization. It is not easy to understand. We don't know where to start. So how do we simplify it? We need to either use a different visualization, okay, or just focus on what we want to point, what we want to emphasize. Good. For example, let's start doing creating this graph, but we need to see the data. Remember, we are visually representing the data in order to make a point. If we see to the left we see a spreadsheet with the data. But the problem here is that if we see the Excel spreadsheet, I mean this spreadsheet here to the left, we don't see any single part in which I can focus. We don't. And if you see to the left, if we see to the right, sorry, we will see that there is a different chart. First, the chart I use to the right is called slope graph, okay, which is a simplified version of a line chart. So we have just 2 points, one like a before and one after, or just 2 simple points. The problem here, or the problem to the left, is that we have the data, but we need to read cell by cell to do our manual comparison. To the right, in the slope graph, it's easier. First, because we have a context, we have a little story. That's one important point. We are helping to create context. After the move to a new website, okay, to a new site, sorry, sale has increased in nearly every department, except with the exception of the department of cheese. Okay, if we see to the left, we don't see any, we have to read the data and manually process the data. To the right, we see that we have created a visual hierarchy, which is cheese. Every other category is going to the right and up, except for cheese. Cheese is a category that is totally different, in comparison, because with the new site, we are actually not making any improvement. It's totally opposite. So what we are doing here, what we are doing with this visualization is, are we making easier the decision? Yes, we are making easier the decision. And how this visualization is helping to make a better decision, because we are emphasizing, we are pointing, we are making a point. The point here is that, it's actually in the story. Every department has increased sales except for the cheese department, or cheese the product. The product is different here. It's different to the rest. Okay, so how do we realize that? We don't even need to see the numbers. Okay, in the columns to the right. We can only focus on the direction of the slope, direction of this line, and we will see that there is a different tendency for the cheese department or cheese product. Okay, this is called a slope graph, which is as I said, a simplified version of a line chart. Okay, we are going to see another different graph. Remember, we are comparing 2 variables. Okay, in this case, I forgot to say that Actually, the variable we're comparing is the old site and new site, but we have subcategories. The categories is old site and new site, and subcategories are every department or every product, okay, or type of product we have in the department. We have like six different departments of type of products. So we are making a comparison. Here we're going to use a different chart, and we are also doing a comparison. So we're going to use something called back-to-back graph. It is very similar to a pyramid, okay, like a Egyptian pyramid, yeah, the same, okay, but there is a special feature of this type of chart. Okay, let's see here. This is the data we have. Okay, we have categories, male and female, and we have subcategories, heart disease, cancer. We are comparing the impact of these diseases, okay, on each gender, male or female. Categories are male or female, and subcategories are the um, the name of the diseases, or every disease. So if we see the data, we see here in the data, we need to manually read every cell with a number to understand, to compare. We need to compare manually, actually with our brain. But what if we do this? Why is it easier to compare, okay, and easier to make a decision using this visualization? Because we are using visuals, but not not a simple visual. Why is it easy to compare? Because, as I said, in my research and exploratory data analysis, okay, we need to have something. We need to have a requirement for a better comparison in bar charts or column charts. We need to have something, a common zero baseline. I mean, all the lines, all the columns, all the bars need to start in a common baseline, and that baseline must start from zero, not from 5, 6, 10. No, it has to start from zero, because if all these bars or columns start from zero, it is easier to compare, very easy to compare. So what we are doing here is comparing male and female, the impact of these diseases in both males and females. Even if I remove the data labels you see in the sites, we are going to see that, for example, heart disease, the disease called heart disease, it has the biggest impact on both males and females. If we want to maybe differentiate the exact number, we will see that it has more impact on males than in females. How this visualization can help us to make a decision? Okay, maybe we'll have to have a little more context, like what is the age gap, for example, of the population, or what was the date or the year of the study. We can have like a little more data in the study, but here we can see that, for example, um, something to see and something to notice, sorry, is that, for example, Alzheimer's disease, okay, has like a twice as much impact, okay, in percentage in females than in males, for example. Even if I don't see the data label, I can see that because of the length of the bar, I can see that this specific disease, Alzheimer's disease, has more impact in females. Okay, and this can help us, can lead to a decision. Okay, let's increase the budget, or let's do something about females are Alzheimer's disease. Okay, it's helping to make a decision. But wait, I mean, wasn't I able to make a decision here? Yes, we were able to make a decision here, but here it's easier to understand. Even a child can understand this because we are using graphs. We are not using raw data. Good. So another kind of usage of back-to-back graph, okay, is this. For example, if you see that have categories that kind of operation comparison to treatment, okay, and we have subcategories, which is the grades, the different grades in schools. For example, you see the story. Students in the program outperform their peers, and students in higher grades saw a bigger impact. So we are comparing the grades of what? Of two groups, two categories, right? For example, you see the treatment and the comparison. Treatment is actually a term that is used when you do a research. Actually, the treatment is a group that you are investigating. That is part of the research, part of investigation. That's a treatment group. Okay, so and the comparison is another group that you are using to compare against. So here we see that that actually the length of the bar determines, okay, how well this group perform in an exam, for example. Okay, you will see that in the treatment group to the right in blue, in light blue, actually outperformed, actually made much better than the counterpart, another group that was being part of the research of the investigation, right? Why is it easy to compare? Because there is a common zero baseline, but subcategories, 8th grade, 10th grade, 12th grade, they all start in a common zero point, common zero baseline, right? So that's the reason why it is easy to compare, okay, with respect to any other chart, for example. We will not be able to use a pie chart here because pie chart actually lack context many times. Even if we actually use a story, it's not easier to compare. We're going to talk about that in another talk. Okay, good. So we can use also a different chart that will make easier the decision making, called the dot plots. What is this? Here we are comparing what? We're comparing two categories, the treatment category and the comparison with a group which is part of research in blue, and another group which is used for comparison. Okay, and this is a category, and the subcategories are the grade that we are researching. Here, for example, it's the same. We have a comparison categories and subcategories. Categories are fall and spring, and the subcategories are the name of each of the courses: literacy, language, mathematics, science, or creative arts. So we want to compare here, we want to compare the results of the students, compare the result of students between two different terms, fall and springs. So we can see here that the categories are, remember, categories are fall and spring, subcategories are the numbers. We see, for example, that at large, in general, the spring students, the students that took the courses in the spring, they actually made better than the students that took the course in fall. Why? Because we see here that we have for each course a different line. Lines are not mixed, okay? This is a dot plot. We are plotting, making, actually visualizing dots. We are comparing with dots. The subcategories, each subcategory, each course has their own line, okay? And the numbers in each category are represented by dots. Here we can see that if we see to the left, in the spreadsheet, if we present this to a decision maker, that person will not be able to notice, tell any difference unless that person reads each cell by one by one. Okay, in comparison to the dot plot in the right. This dot plot in the right is better, it's better communicating. And what is the purpose? What is the point that we want to make? Easy. That point, you can read it in the story. Students, okay, students, if you compare fall and spring, actually made better in sprints. In sprint, sorry. Actually, if you take a course in sprint, you actually could do better than if you have taken that course in fall. But how, I mean, what, how you see the difference? Because of the position of the point. If you see in the bottom part of the graph, you see they start with 0. I mean, all points start from 0, and they end up they finish in 100. So the more closer to the right the point is, actually the higher the grade that you obtain in either fall or spring semesters, right? This is called the plot, dot plot graph. What we are using it for? We are using it to compare two numbers. Actually, it's not only two numbers. There are like two categories and different subcategories. Okay, I like to use line graph. Line graph are especially useful when we have a timeline. What does it mean? That the we have two lines, a vertical line and horizontal line. The horizontal line is called the X, okay, the X line. And when we use the X line, okay, which is horizontal, we use time data. For example, days, weeks, years, months, hours, any type of data which is related to date or time. So here we are comparing these numbers, these categories, which are regions, okay, uh, but these regions are very similar among them. We are comparing, and we don't have, much clear what is that difference. Because all of them are mixing in one chart. So, but why? Because bar charts are, line charts, sorry, are very effective. But the problem here is that they are mixing so much that we cannot tell. It's different. It's very difficult to tell a difference in these charts. Actually, in every region, in the one of the 6 regions. So we have split in 6. We have actually created different numbers, or no, not numbers, different different timelines or different line charts for each category, right? What is the effect of this? First, they all start from 0. So there is a common 0 baseline. Secondly, if we compare here each one of these categories, we'll see that we don't need to compare one over another. We can compare, okay, it's easier to compare because they are in parallel. They have a common Y line, Y column, which allows us to compare. So here I can see, look, how every region has improved. Here I see that the region E, for example, is doing well. If you see here, for example, region E is doing well. But something that I have not noticed is that region C is actually more uniform. They are more uniform, and they are improving, okay, at a more uniform way. But here is very different. It's very difficult to see. We can see there is a gray line, okay, but it's not difficult to see, to tell. Here it's easier to tell because we are not putting line over line, okay. These lines are not colliding with them. These lines are independent, so they better represent the point that we want to represent is, for example, that region C is growing at a constant pace, for example, and region F is decreasing. So this is one, or even 2 points that I'm making. Okay, region C is like steady growth, has steady growth, and region F is not growing, actually is shrinking. Okay, or is not doing that well. Okay, there's something also called the dot and whisker plots. What do we do with this? This is kind of new. Okay, in statistics, there is something called average, and there is something called standard errors. Okay, so these dot and whisker plots. The dots are, I mean, that dot, the black dot that you see there. Okay, we see there, they're the dots, and the whiskers. Okay, are these lines that, I mean, over and below the points that represent the error. Okay, actually the margin that that these numbers fall into. For example, we are seeing the performance of 3 marketing campaigns, right? The performance of 3 marketing campaigns, and we can see that the marketing campaign C is doing much better. Okay, there is an average, okay, of 40%, but we see that I mean, even that 14% can be even like 36% because there is a percentage of rate error, okay, that might not be that exact. Okay, it could be like 4%, 4% above or below 40%. This is the error margin in the average. The average is 40 and the error margin is like 4%, right? Okay, but there is something that we have to explain here. Not everyone understands what the average is and what the error margin is. So we need to create context, as I just said before. We need to explain. We cannot assume that everyone will understand what we are doing. For example, here we are using the dot and whisker plots, okay? But we are, I mean, actually this graph is like very similar, but we are using an story. We're using context. For example, campaigns A and C perform well, okay, similar, but we explain that gray bars, in the bars above and below the points, actually indicate standard error, the error margin. Okay, and for example, we are not doing an exact measurement. There is a possible error, and how much that error could be, like 4%, around 4%. But we explain that in the graph. So we are creating context. No matter if you are not an expert in statistics, you can see that we are explaining. I mean, it's possible you understand because the language is very simple to understand. So we need to remember to always create a context, if the even if this chart is very simple to understand. We cannot assume that everyone will possibly know what we know about the type of charts. And we can also use a whisker plot, but in a timeline. You see that line, that blue line is the average, and you see the whiskers. Okay, this is a great spread, a gray zone. Okay, we are using a context here. The gray area, okay, above and below this line, the average line, is the spread, okay, which is the error margin that might be possible. We need to apply to each average. Okay, so we are combining a timeline and a dot and whisker plot. There is also something very similar, which is a box and whisker plot. We're not explain because of time constraints. So now to finish the talk, we are going to talk. We are going to see how we are going to visualize benchmarks. So we are visualizing data. We are using visualizations to compare, not not to show one, not to compare between two or more. We are using visualizations to make easier to compare comparisons against a benchmark. Look, if we see here, for example, we have the data there. The data, we have a group, I mean, we have a performance, okay, data column, and we have 3 categories, group A, B, and C. And we have a benchmark, which is 65. We here in this, I mean, all the graph I'm presenting can be done in Excel. Every chart I'm using here is, I mean, it's actually supported by Excel. here, for example, okay, two of the three groups, okay, in this data did not meet the performance benchmark this year. The performance was, was supposed to be about 55%, but only one group, Group C, actually surpassed that benchmark. Okay, we are using here a single benchmark line. line. And what about if the benchmark, the comparison against benchmark, is not one single benchmark for all categories, but each category has a different benchmark? So we can use a specific benchmark, a custom benchmark for each of the categories, right? It is also possible to do it. You don't have to have one single benchmark. We have to use all the resources, all the possible resources, including different benchmark for each category, 60, 65, and 75%. Okay, and to finish the presentation, we can have overlapping bars. These are actually bars or columns. Okay, if it's vertical, it should be called a column, but it's the same most of the time. Okay, we are comparing against a benchmark, which is the budget. Okay, each category, each bucket, we have five buckets, sorry. Each bucket has a different benchmark. Okay, and instead of using the data label or using a line, okay, we are going to use a different column, but with a wider column. So the budget that we need to compare against is in gray, and the actual revenue, the actual amount, it's in blue. It's in light blue. So here we can see that only three of the five categories or buckets surpass the benchmark that they were set. Okay, and bucket C and bucket D, they did not pass their personalized benchmark. It is easy to tell a story using bars. Actually, this is called overlapping bars. What's my point here? The point is mentioned in the story. Buckets A and B exceeded their budgeted amount this quarter. Okay, so we don't need to have a single line or a single chart. We can use actually an overlapping bar or overlapping column to understand the story better. So the best book I recommend to use that can help us to um, understand how to pick the right data visualization for every case, for every scenario, is the book called Effective Data Visualization, The Right Chart for the Right Data by Stephanie Evergreen. I love this book because this book actually first is all done in Excel. We can use every example is done in Excel. Second, okay, this book is based on case studies. Actually, it's a case-based book. We have cases, we have problems that we need to solve using visualizations. So it's the best book, in my opinion, on specifically data visualization, how to pick the right data, and how to introduce stories to help make a better decision. Good. So this is the end of the webinar, but I would like to invite you to follow me on LinkedIn or drop me a line to my email address, ferrandis@coreanalitica.com. I would love to be connected with you, even if you see this presentation after the live stream. And I invite you to subscribe to our newsletter, okay, at coreanalitica.com and follow us on LinkedIn. We have every month we publish 2 articles about data visualization, about software, about machine learning, about BI, about data related stuff. So I would like to invite you to join this community, to join this newsletter, and follow us on LinkedIn, where we usually publish some updates. So that's it. Thank you for your attention. I hope that if you are watching this webinar after the live transmission, it can be useful for you. Okay. You can also write your comments or question in the comment board. Okay, and we will gladly will be very happy to answer your questions. Okay, that's it. Thank you for watching this webinar, and don't forget to subscribe to our newsletter and follow us on LinkedIn. Okay, that's it. Thank you for now, and I see you in the next data webinar of Core Analytica. Bye bye.